professorial. I've been professor now for 35 or 40 years, so it's not an easy transition. And I first wanted to thank Gunnar. I don't think he said a single thing that I would disagree with, so it was a very nice opening. What I want to focus on for you today is the situation in Texas. So some newer work that has come out, especially by my colleague John Nielsen Gammon, who couldn't be here. He's our state climatologist and also professor at Texas A&M in the same department that I'm in. In fact, many years ago when I was a department head, I appointed him, and actually when George Bush was the governor, we appointed John Nielsen Gammon to be the state climatologist. So one thing that Russ wanted me to mention, and I actually didn't have time to get it in there, is there is a book that was just published this year by the University of Texas Press, and Nielsen Gammon has a chapter in that book. I'm one of the editors, along with Jürgen Schmont, who's a professor emeritus in political science over at UT. And we tried to bring the two institutions together on this, not an easy thing to do. But we tried to give a kind of nonpartisan picture of what we thought would happen in the state of Texas over the next tens of years. And so I'm touching on some of those things in the talk today because I thought it would be a little bit more interesting than hearing more of the same. Here is one. I thought that might go over well in the script. Anyway, just this week in the New Yorker.
From that liberal publication.
Now, here is a picture of what's happened in this year in College Station. And if you go to the National Weather Service website, you can do this, but apparently they don't have this particular kind of graphic for San Antonio. It's too bad because I really do like this one. What it shows, I don't have a pointer, but we don't really need it. What it shows is the temperature daily going up until today. What you see is that in the spring part of the winter and spring part of the year, a lot of up and down fluctuations in temperature. Oh, you do have something.
Yeah, but the battery's low.
I think you have a bit. Yeah, what you see in the winter and spring part of the year, lots of fluctuations, and I think you all know that those are due to fronts. Fronts come. We just had one come through last night. No rain, unfortunately, with it, but we did have a nice one come through here last night, and I'll show you that weather map in just a moment. But through the summer, see, once June gets here, notice there's one little glitch there. That was a front that passed in College Station in June. But after that, notice that it's very tight. And the red line there is 100 degrees. So you can see in the daytime, the temperature goes up to 100 degrees or so. At night, it comes down. But note in the green area, the green band there is kind of the average over time. And you can see that all of the summer this year was way above average. And there were even a few records set here in College Station. And for the state as a whole, we set records all over the place. So one thing that's very interesting about climate change is how long is our summer when we have no fronts that pass? And what models tell us is that tropical time of the year, here in San Antonio it's a little wider than it is in College Station, that tropical time of the year is going to expand a little bit. In other words, the storms that pass through the middle latitudes from west to east all through our winter time, they're going to move a little bit to the north. So the north part of our country is going to get more rain, and our part of the country is going to have an expanded summer with less rain. And so we've already seen this year is kind of a prototype of that, although this year was a big fluctuation in that direction. This year, you can see floods in the northern part of our country and drought in the southern part of our country. And so this is the kind of slight exaggeration, but this is the sort of trend that we might expect in the next few tens of years. I'll come back to that. But anyway, so here is what it might be like in another few tens of years. So here is the cold front that just passed through, just to emphasize how the fluctuations work. Here's the little cold front that passed through last night. You can see the front. Everybody knows how to read weather maps nowadays. And this one shows rain, precipitation in College Station this year. So the brown curve, the curve up above, is normal. And then you see down below, the green is where we are now. And at this time, we have 12.6 inches of rain accumulated this year in College Station. But we should expect where the brown curve is, which is a little bit more. And by the way, let's like I said, didn't get what I wanted to put on here, but you can easily correlate these fronts with the little jumps in our rainfall this year. So this gives you a little idea, this broad, flat area in the summertime, that's what we might expect to expand. And also, it might go up a little bit as we go on. So there are two things going on. One is the temperature in general will be going up, and also our summer dry period will go up a little higher. That's what Bob was telling me. It's a pretty robust conclusion from the model. This is now for the whole state of Texas, put together by my colleague John Nilsen, again, who I mentioned. And by the way, he has a great blog. If you ever like to look at blogs, it's hard to find because it's through the Houston Chronicle. But if you put the name of it, Climate Abyss, which is what he calls it, if you put that in Google, it'll appear on a couple more if you want to notice. But it's a great blog. It's very sensible. It's not a crazy advocating thing. It's not a skeptical thing. He's very moderate in the way he approaches this. He's a great scientist. So here's the histogram that John put together for the state of Texas in August. So if you look at all the Augusts going back, you all know what the normal curve looks like for a histogram. This is not that far from it. So you see this nice normal curve. This is for all the years in the past that we have records for the whole state of Texas. And now, here's what our year this year. This was August this year. Look, it's not out of that distribution, right? If you were a statistician and you were asking, is this from another planet? You'd have to say, yeah, probably. It probably doesn't come from here. So this is where it was. And he said, well, actually, it was right at the end of August. I think it was one day to go. He put this in his blog, and I just downloaded it for you. But look, this year is really out of bounds. This is a really crazy year. And I'm not attributing all of it, and you'll see tomorrow in a moment, to global warming. But it is something that we might expect. I mean, this is a very, very unusual time. And we're going into what we might call the Anthropocene, when men, humans, are really having a significant influence on our planet. Gunnar has already mentioned that. Now, there's another thing that really influences our weather here in Texas. And first, let me just show you what NOAA, the National Oceanographic and Atmospheric Administration, what they say is likely to happen in the next few months, October, November, December this year. And their forecast is that we will have more drought in the south. So Texas and through the southeast, even more of the same. Why is that? Well, I'll show you. I'll try to give you some insight. And also temperature. It's going to be hotter. NOAA says it's going to be hotter, and this is probably the most reliable source of information that you can get on this. It's from the Climate Prediction Center of NOAA. So probably the most, it's not, when we make a climate forecast out of a whole season, it's not perfectly good. And so when they indicate that 70 there in Texas means it's a 70% chance it'll be warmer than normal. That's what that means. Not 70 degrees warmer. Okay. Now, why is this? How did NOAA base this prediction that it would be warm? Well, things are going on out in the Pacific Ocean. And we have these things called El Nino and La Nina. They're the two swings of things that happen out in the Pacific. Can everybody hear me okay? So, this is a picture showing going down into the ocean 300 meters Here's the date line out of the middle of the Pacific. And what you see in blue here means colder than normal, and the yellow and brown mean that it's warmer than normal. So what's happening is the water just below the surface is cooler than normal right now. And we have just gone through a kind of zigzag, and I'll show you that now, of temperatures out in the Pacific. Why does that influence things going on here? Well, I mentioned the storm belt that goes around in the wintertime. That storm belt is actually the location of it and how the jet stream and all those things work together. It's influenced by these temperatures along the equator in the Pacific Ocean. So they do have an influence on that. And meteorologists have found that there's some predictive value in knowing the temperature out in the Pacific. It goes over many, many years. I'll show you a few more graphics that will take more convention. But here's what's happening to the temperature in the upper layer of the ocean from the date line east. So in last winter, we had a strong La Nina. That is, it was cold out in the Pacific. For the surface waters there were cold. That influenced the storm belt, gave us a drought in the winter. So in the summertime, this doesn't make much difference. Right, no fronts anyway here. Right, no fronts. So it has no effect on us in the summer, but it has a big effect in the winter. It means storms come or don't come. And so La Nina inhibits storms from coming down this far. You get some, but not as many as usual. So we finished up with this La Nina. No rain all winter. Poor guys raising cattle, no grass, no green grass. And we just drove across Texas, and it's horrible. Well, then it sort of broke in the late spring, and we experienced a warming out there in the Pacific. And so it was a kind of mild El Nino. But lo and behold, the darn thing's coming back. So what they think now is that this will, and there are oceanographers who follow this very closely, and their predictions are we're in for another one. So next year is likely to be similar to this year, next winter. This is not good news. So Gunnar brought you good bad news. So here I am. This is just short-term stuff, you know. This has nothing to do with global warming. It's just short-term stuff. So now just to show you how during El Nino years on the left and La Nina year, this is from data, it's from history of these things going back 50 years or so. What it shows you to see is when there's an El Nino, it's cool in our part of the state. We have a cool winter, but when there's La Nina, it's hot down here. And so we've gone through many of these. They repeat over 2 to 6 year cycles. It's irregular. But you see, when there's a La Nina, it tends to be hot. There are 2 reasons. One is it's not so cloudy, right? Those storms don't come down. The storms tend to cool us. So that's one reason. So here, we look at precipitation. Here's the bad news, right? There's La Nina. There's what happens. So that's what we're in for, probably in the coming winter, is a very dry winter. And then, of course, that will be followed by what's normally a dry summer anyway, right? So we're looking at dry. And this one shows you how this is a graph of all each point here is a year in the past, and it shows you that over here on the vertical axis is the temperature, and over there on the horizontal axis is the rainfall. So temperature versus rainfall. And what you see is the black line shows us is that when it's cool, we get more rain. Or another way of looking at it is when we get more rain, it's cool. You know, this is a correlation, not a causality. But look at 2011. Look at that thing. I don't even see 1957 in this, right? Where is it? Right, that's the drought of record that our hydrologists, the Texas Water Development Board, who I'm in trouble with all the time, that's the drought of record. That's what we plan on, is the drought of record. I can't even find it. I I get in a lot of trouble. All right, now we're going to turn to the future. We'll talk about global warming. Okay, so now we've got this big elephant in the room, La Niñas, that are going back and forth. So they rattle back and forth while this rather slow process of global warming is happening. So global warming is not big yet, but it's going to be. And so I'll try to give you some idea about that. So this one now, it's got El Niños in it. These are model forecasts of what it's going to be like toward the end of the century compared to now. So the last decade of the century compared with the last decade of nearly the last century. So here's the picture. During the winter months, there is a big effect. Summer months, where it's light here, it means that the models don't agree with it. Basically, nothing happens, right? So what I wrote on there was hard to tell. No big change in the summertime. It's the wintertime that really matters, right? So you see that dryer coming out from Mexico? It's not just people. It's that dry coming up here. And in winter, it's going to be wetter up there. So here's the little maximum that I come up with. I say this all the time. My rule, where it's wet, is going to get wetter in this country, and where it's dry, it's probably going to get drier. So that's a simple message. Here is a thing that was compiled by Nielsen Gamma. Each of these colors here are precipitation in different sections of the state. You don't need to pay much attention to which one is which, but what you see is that actually there was an increase in precipitation for some years from the 50s on. But the forecasts are out there, those funny looking things out there called box and whisker diagrams. The one in the dark line in the middle is the median, and then 50% of the thing is supposed to be in between. So, and this is one of the A1B projection. Gunnar showed you that. That's almost a business as usual kind of. In other words, you're not doing anything about it. But none of those different scenarios are very different in the first 50 years. So this gives you some idea that at the end of the century, as you go out to 2060, probably precipitation in the state of Texas will go down some. It won't be huge for the whole state. Probably in the northern part it won't be so bad, in the southern part it will be. Now I can't say these models are perfect. You know, we had the southwest monsoon. We were just in Arizona a week ago, and it poured rain all the time. Out in El Paso, they finally get a drink out there, usually in August and September. The rain creeps up Mexico's western coast, and into those areas in the late summer. But this is what we might expect. Now here's the bad news. For those of us who have to work outside this is what the temperature is likely to be. And this is really ugly. I mean, see, it started to warm. Finally, Texas got on board. It really started to warm. For a long time, a lot of deniers, when I would go out and give these talks, they said, well, it's been cooling in Texas. What are you talking about? That was back then. But now Texas has finally gotten on board. This cooling probably had something to do with the Gulf of Mexico and the change of waters there. But now, this is what our models say about the state of Texas into the future. So you see that this particular August was about 3 degrees, these are in Fahrenheit. So what this says is that if you look at that change from 0 there up to 3, notice that we were about 3 degrees above the norm. So if we were to put this summer in Texas on there, we would be up there at about the 3 level. So what we're saying is that, you know, that's what we might expect in the decades to come. Something like this summer. This summer, it's not going to be hotter and hotter and hotter. Next summer may be hot, but probably the one after will not. You know, so there's a large amount of natural variability on top of these trends. We all have to recognize that. You always hear climatologists say, now wait a minute, you can't blame any event on global warming. There's this, like the stock market, you can't, you know, that thing's all over the place, right? Just my retirement money. I'm not retired yet, I may never retire. Well, as we drove across Texas from Arizona, Laura and I, at the weekend, we did go up through Bastrop, and we came down again last night. And so, of course, it's not like this now, but it's pretty horrible over there. And I just wanted to emphasize again what Gunnar said, was that one of the consequences of this warming and drying is the likelihood of more fires in Texas. So that's a consequence for our state. So, you know, it's not said very much, but our state is really one of the more vulnerable of the states in the United States when it comes to global warming. Because we also have this crazy El Nino, La Nina cycle, which doesn't affect the rest of the country as much as it does here. Here's one more. This is what it would look like as we drove through. All of these beautiful, wonderful pine trees just blackened all the way up for some historic completely. But most of them didn't burn all of the wood, it just burned the bark all the way up the tree. It was really quite sad. All right. Now, on the precipitation, I quoted this right out of John's law. So precipitation. So the balance of evidence does not support the assertion that the rainfall deficit since October was made larger by global warming. No, it's really the circulation shift. Temperature compared to long-range averages, well, rainfall deficit. So he says, you see, that the rainfall deficit accounted for about 4 degrees of excess heat. See, when the ground is wet and you heat up the atmosphere, it evaporates water, and that's like the surface sweats. So it cools it. Right? So that cools the air, not only that, but the clouds. So he says, well, the rainfall deficit probably accounted for about 4 degrees of excess heat. Global warming accounted for about 1 degree Fahrenheit of excess heat. So the warmer temperatures led to greater water demand, faster evaporation, all these things. Thus, the impacts of drought were enhanced by global warming, much of which was caused by man, which is exactly what we understand. So what we can say is that, well, our hot, dry summer had some, we could attribute part of it to the global warming, but a lot of it was this other thing. And by the way, on El Nino, La Nina, we don't know yet whether there will be more or less, or more intense or less of these things in the future. Our models are not good enough yet to make a firm prediction about that. But it's my opinion that in the next 5 to 10 years, our models are improving very rapidly. And I think we will have much more predictability about the future of hurricanes and the future of the El Nino cycle in the next 5 to 10 years. We're not ready on that yet. So again, we don't know about the hurricanes. We do know about temperature a lot. We know about sea level going up, no doubt. Why? You warm the water and it expands. That's the main reason. Then there's also glaciers melting. All right, I'm just about. So here, I want to give a couple of thoughts on what ought to be done. How do we do it? What do we do now? And here really comes the hard question. I'm a scientist and have been for 45 years since I got my PhD. And I cannot claim to know who should be the winners and who should be the losers. That's not in my job description, or even in my portfolio of abilities, many as there are. Who do you turn to? Who do we ask? So I just thought we'd go through a few of these. Well, you know, the celebrities, right? They're there, and they're always ready to come out and give you their opinion and do often good things. But you know, they're sincere perhaps, but they're not always informed very well. So that's not a very good place to get their information or decide what to do. Although it does get our attention, and that's not all bad. Religious leaders, well, religious leaders, you know, they're the people that we might, you know, in principle, They're the people that you might want to go to for moral choices about what's right and what's wrong. Who should be winners and who should be losers. But you know, it doesn't always mix right now. In particular, we seem to have battles within the religious community over the science, let alone what to do about it. So I'm not so sure right now. I think there may be a vibe that indicates no. I don't want to put them down. I think people are sincere. They're doing what they think is right. But I'm not so sure it's exactly where we want to go. Universities, well, they're mostly reliable. I'll grant that. But also universities are really strongly under influence these days, just as they are in the medical business, biases because of the encroachment of corporations into that culture. I do think there's something there. I don't think it's happened in the global warming business, but I think it is possible. For instance, here we are in the state of Texas. I cannot name a single scientist who works in the climate field who is a climate change denier. There is not one. I've had two big forum debates in the last year, and they had to go way out of state to find somebody to debate on the other side. They said, well, isn't anybody in Texas? Quite a few people at UT, quite a few people at A&M, and other universities as well. We can't find them. There are not any of them. We have 16 people in our department. Every single one endorses basically what they were saying. Okay. Corporations? Well, corporations, well, you know, I mean, some are good, some are bad. Even Enron wanted to be on the right side. They found that they tried to find a business model that would make money and also do good. Even Enron. But the fact is, there's no mechanism in our corporate structure, in my opinion, that has a kind of moral compass to it, right? I'm about to retire here in a few decades. So I really depend on my mutual funds and my 401 or 403, whatever it is. I depend. But you know, what do I ask when I go to my mutual fund, my finance guy? I don't say, oh, let's go here, go there. No. I want, and all of you who are about to retire, you want a good return on your money. So there is no incentive in corporations to worry about this stuff. They're worried about satisfying shareholders. So it's not a very good place to go for answers to this question. What about elected officials? Well, government, and you know, elected officials and government, they're really not quite the same. You have all the civil servants. I was one for 8 years before I came to A&M. But government right now and elected officials, pretty dysfunctional right now, right? In fact, it's pretty hard to raise the issue of global warming in Washington. You've done a good job here in San Antonio. It's amazing, really amazing. But you know, I really applaud your efforts here. But things in Washington right now are really very dysfunctional. And in fact, the whole Congress seems to be in a kind of crisis mode. And they just can't keep outside that. So that's not. So here's the answer, if there is one. The people. So, you know, it's people like this. It's people out there, and the state rep here, Mr. Villarreal, really said it earlier. You know, we just talk to our friends. We slowly but surely gain some ground by telling our friends and community what we think is right. So we're all frail, you know, we all are subject to all the faults of all these other people that I brought up. But probably still the last best hope is to get people behind this. And as our economy recovers and so on, maybe we'll be able to do something on a national scale.